So thanks everybody for joining today. We're going to be doing an update talk. We've already talked about the CC Star data movement workshop and data exposition a couple of times over the past year, but now we wanted to provide an update on how the program is going and what the trajectory is going to be going forward, since we're not able to have the CC Star PI meeting in person this year. We still wanted to give everybody an update on how it was going and how everybody can participate going forward. So I'm going to turn it over to Ken Miller from ESnet, who's going to give the update of this today. And if anybody does have questions during the talk, please type them into the chat room and we'll make sure that they get answered. So take it away, Ken.
All right. Hi, everyone. I'm going to start out with just a quick little refresher on a few highlights of what we've worked with before. And then from there, kind of the basis of this is just really paying attention to how your data transfers are going. This observation, from the ESnet did with a few other sites a couple years ago was around a consistent data set being transferred and, kind of mapping out where the transfers were going. Looking at these pieces, what you try to understand what what the researchers see when they're doing this kind of work, and really what they see is what speed they're transferring at. All the other pieces in the middle really are not very visible to them. So really what they see is like how long it takes to move some of the data, how long it takes to address the workflows in pieces like this. So this observation was built, on top of a science DMZ model, broken out into a few other larger facilities around the country with a reference data set that has actually been used. And the goal was to try to get, a petabyte a week, around 15 gigabits a second for this effort. So the initial tests were like on this sheet, kind of broken up in between sites as you start doing this kind of visibility, and you really try to see what your throughput is and what transfers you're getting to understand what the real life situation is versus what the potential could be with some of these transfers. And if you start documenting all this and do these tests every few months, once a quarter, something like that with your existing infrastructure, it's a good habit to get into, and as well as trying to understand what the potential of your systems are. And then with this project, around 18 months later, you kind of see what the results turned into, from single gigabit transfers into multi-gigabit and sometimes over 50 gigabits a second on some of these sites. So that's kind of the idea where this is coming in from, just really what you're paying attention to and what's happening with some of these transfers, and understanding what your infrastructure capabilities are and what the potential could be. So this exhibition kind of gets into some of this, understanding where I guess with the new CC Star coming out and some people that maybe a year or two into their projects, this is a good habit to get into, of just getting a good baseline of what your systems are, what they can do, and what the researchers should expect. And a lot of times, given the results as of a few years ago, 5 to 6 gigabits a second on a parallel transfer, we should easily be seeing those systems like that on 10 gigabit connections now. And with the endpoints included in this project, these are 40 to 400 gigabit systems. So your 10 gigabits on your campuses should be able to push these limits pretty good. So a lot of this behind this is kind of raise your expectations to at least a 5 gigabit per second transfer to and from some of these sites as part of this. So we're getting into the exhibition piece. We've talked about this different times. It's kind of a refresher for some people that are new to the CC Star, or they're just kind of getting looped into this. There's past presentations we can link you to that explain this a lot further detail. So where these kind of get into is really understanding what the data transfers are, how it affects the workflow, but really to baseline your systems to see where they're at and see what kind of even like a performance level they should be at. I know there's really not SLAs on data transfers. Maybe it's something you want to look into, but on your own campus. But for this instance, it's really just trying to understand what you have and how much you can transfer. So this kind of gets into the name from before. Sometimes around this, there's a lot of information can be transferred, but I guess really unless you're really pulsing and trying to understand what your researchers are getting and you really have a lot of engagement with them, the best way to do it is to try to baseline your transfers as well as look at some of your data. So, so the idea behind this is all these IT systems are really separated. Then everyone is building their own systems, but the transfers and the way that the science is really happening is, multiple networks. And so to coordinate that effort with different, IT groups, different system builds, different types of science, there could be a multitude of issues in doing these transfers. So this is, again, as a project to kind of baseline some of your data. So the start of this started last year. We're about 9 months into the project right now, and we've had a number of tests really since the last presentation we gave, and it's been increased quite a bit. But again, I think we're going to extend this another year to try to look at some other opportunities to see what we can test and get into. So again, here we're going to extend it. But from there, just try to understand, with these reference data sets and testing out your environment. Some people have actually used this to stress test their storage system. Some people have used this to, understand how this new system may be tuned or a different network architecture. And some of these pieces get into that. And this is providing a consistent endpoint to test to and from this project. So the idea behind a lot of this is really just building out your test set and documenting that. And then we'd like to be able to share out, the number of tests that are there. And I have some of the data in a little bit we'll get into. But from there, there's also a potential to do a little write-up of what your architecture is, your topology, and then also including your testing results in that, so that this is something that we can share and raise the community knowledge about what's really happening out there, as well as where our potential should be. Should we be testing at 25 gigabits a second, things like that on some of these larger systems? Should we, on a 10 gigabit system, is 2 gigs okay, or should it be near 8 now? Things like that. So this effort is really around trying to gather data for the community, but also to verify your own installations. So, like I said, this started last year. We're going to go through this year for the full year of 1 year, and then now we're going to be extending it another year in the future. If you need any help on reviews of your current infrastructure, or you do CC Star awards, we have some contact information later on. With this, we can get into reviewing architectures, science, some of the workflows, some of the size data sets, some of the destinations you may be going to just to share your data or collect the data. Some of those reviews we can also help out with. So getting into the current status of where this is at. So far, there's been 665 tests completed. So in the last 9 months, from the previous, I think since 3 months ago, there were around 15 known sites that were being tested to and from. There were a handful of other that had some incomplete tests and some details here, but so far 41 sites have downloaded test data. So using the DME endpoints, 41 individual sites have actually pulled data down from those so far. And on the upload side of it, there's been 18 sites that have done the upload. And this includes taking away the DME endpoints as part of the source destination. So this is excluding the known endpoints that we have. This is just users testing based off this program. The breakdown of sites like this, this includes all sites that were sourced of data, so downloading data or from individual DME sites, as well as sourced from your campus up to one of the writing sites, where you can actually try to push your data and see how long it's going to take to write there. So you can see the system at Cornell is running, I think, 220 tests or something like that so far. Some of the other pieces, it really just is just varied, but you see a lot more people have been downloading sites than uploading, to really try to trust your how much you're receiving data. Destination by sites, you can see here that sites have been trying to, for the writing side of things, pushing data out, or sites that have been downloading data directly to them as part of the data sets. It's pretty a wide scale of the tests going on and some of the counts. But again, this has greatly increased and just in the last 3 to 4 months since the last report from this standpoint. So these are kind of the trend of the graphs right there. So some of the just individual metrics on some of the sites. We're focusing on the DMA endpoints because they're kind of the control in the situation. We know that they can perform well and they do. So looking at the average test to there, as well as the average speed of the transfer, will kind of give us a decent baseline of what the end users are getting from that standpoint. So we talked about that a little before, like what should the expectations be from some of these sites, and what should the expectations be based off your site or your infrastructure or the equipment you have or how well it's tuned. So again, this was the test that had the Cornell site had the most transfers to as a source. The average speed so far with the 220 transfers is 2.55 gigabits a second. So we know these systems can do a lot higher, but in this case, this is trying to see what the average speed was from this control endpoint, if you will, in this DME endpoints. So that's a little lower than the 5 to 6.6 gigabits a second we were discussing before. But some of these endpoints could be 1 gig testers going to these sites. So we don't have that information broken out, and that's something I have in my notes for potential next part of the report. What are the speeds and some of the more meta information about each of these test sites. One of the peak pieces with a 24 gigabits a second transfer to, I think it was Kansas, was one of the peaks on that instance. So that was pretty good for a campus network. As a destination, there were 78 transfers writing back to Cornell. And so, like I said, 4.48 gigabits a second for the control there. So that was actually pretty good as an average based on the 78 transfers. So that was pretty decent. I think I have my numbers messed up here. Sorry. The DME data sets in Boston, 78 is the source, and 41 transfers as destination. These numbers look the same. I probably copied them in wrong. I can verify those, but from there, but like I said, the source and destination for Boston, that's where I can update the slides when it's at the end for the actual average transfer speeds if they are incorrect. So this next data set from the control, the AT transfers as source, 1 gigabits a second average transfer there, and 7 transfers as for write up to this DME endpoint, and around the same 1.75 gigabits a second average transfer. Argon was a little bit different at 78 or 68 as the source, 5.24 for the average read, pulling data down, and then 67 transfers as the destination. So people are writing back to that. That was actually, I think, the highest average we had was 9.5 gigabits a second. The Michigan site, there was an issue getting into some of that. That's why the asterisk is there. So it's as we're pulling this data, I didn't see the numbers coming back, and then we did a couple transfers, and different times that Globus is not connecting to that properly. So that's a follow-up we have to double check on that for the next quarter of stats. So and then the system at NCAR was probably used the second most, and it had decent performance as well as an average. 85 transfers is sourced from there on an average of 5.18 gigabits a second downloads, and 99 transfers is a destination on the right with 4.39 gigabits a second average. I think this one had the peak transfer of 69 gigabits a second between two of these DME endpoints. So that was, pretty impressive as a transfer speed for a maximum. But like I said, these are the averages from the data sets included there. So The other side of it was on the right side, the DMA Cloud Connections. They're set up through the Globus connection endpoints. There were only a handful of people writing out to the cloud drives, so we'd like to get more information there if we can. People are actually looking to test out the Google or Box, or if there's any other connectors we could look into. But right now, these are the pieces there. You can see it's the cloud drives off at throttle the data. So one of the pieces we're looking at is the size of the data sets, the amount of files in them. So some of the stats we don't have are broken out, the transfer speeds by the data sets. So that's something else that I have in my notes to review for the next quarter report as well. So if we can get individual stats from the transfers to see that what the actual transfer speeds maximum and average are for the individual data sets shared as part of the DME, that might be able to break this down into more of a granular fashion to understand, large files versus small files to each of these sites to see how well the systems are doing. So some of this is, like I said, a repeat from before with a couple new additions to it. The larger sites from the DME and the NCAR petrol system performed quite well based on this from the average stats and the number of times they've been tested. Some other sites have some other larger nodes that campuses are hitting over 10 gigabits now. Like I said, that one was up 24 gigabits a second. So there are pieces like that some of these are really pushing past 10 gigabits now, which is fantastic. That's actually what the effort behind this project is try to see where data transfers are, where they should be from a campus perspective. The like I said, the one there was the NCAR piece from last time. There was 50 gigabit transfer. I think that's actually there's a couple over 50 now, and I think the one was as high as 65, 69, something like that. That was pretty interesting in the numbers. A few of the sites at Purdue, we're doing over 10 gigabits a second. The one here at Kansas to Cornell was, like I said, the 24 gigabits is a maximum. I think that was one of the higher campuses we had that was doing the transfer there. And then there was a write from Sanren, Globus transfer of 7.3 gigabits a second to NCAR. So that's quite a bit of distance. So there's some further follow-up there we want to take a look at to see what the latency and maybe the distance and some of the other information around some of these international transfers as they're coming in through this program.
So we had a question come in that would be good to address right now, Ken. So Doug wants to know or states, since DME allows an institution to see actual performance set expectations for a transfer, it somewhat overlaps with PerfSonar. Have you had any instances where PerfSonar tests either looked very similar or very different from DME? Understanding, of course, that PerfSonar tests are memory and not disk.
We didn't have any data to correlate with that, actually. So we could probably do that on a case-by-case basis if we see a test, if we want to look in a little further into that. If there's a ways to gather more data out of the logs we have to be able to look at some of these, then we can take a look at that. But I think that would be an interesting baseline to see, the network capacity versus the actual data transfer speed to correlate those two pieces of information. Typically, that's what you do when we're troubleshooting data transfer slowness anyway. So, but we didn't have the two different data sets like that to correlate. So.
Okay. And second question is, Phil wants to know, are tests in this sense the entire set of the files or just a group at a time?
I believe these are just individual data set transfers. So as you look at the DME data sets, I think each of these is the actual transaction log of the individual transfer. Now, I don't know if you include multiple folders in that. We can probably break that out by the amount of bytes transferred and verify that. But the logs we have just show the data transfer rate, the source and destination, the amount of bytes transferred, and then the duration is all the data we have to mine right now. So that's why I'm saying in the future. Now I have a discussion slide here in a little bit. So if there's other pieces like that we want to look into to break this out a little further, we can look into that. So, but that's all we had so far was just those 5 or 6 fields to go off of. So.
Okay. And then this one was already answered in the chat room, but I'll just state it for the record. Yes, Globus is the supported mechanism for this set of tests right now. It is possible to set this up to use other mechanisms, but this is what we chose because it's ubiquitous. It's available at a lot of campuses, and this was easiest to sort of get up and running.
Okay.
So you can continue.
All right. So like I said, there were a couple other different sites, you know, many across the U.S. There were some international, including, like I said, the college in London here. That one's test from Sanran. And there was another one too that I just noticed. From there, there were different data sets or different tests from, they're actually were peaking higher than 10 gigs. So that was actually great. Some of the other pieces, you know, were that the data sets so far, given the data we did have, where we could drill into this a little further and actually break it out by data sets or break it out by individual components. If we had better data around each data point, whether it, hopefully there's jumbo frames enabled, but whether it had a disk locally to the machine, whether that was connected to a parallel file system or something like that. So there, you know, the speeds so far, just as the initial metric, have increased a little bit in the last few months. So that's fantastic. But like I said, there are some other pieces in here that we might be able to correlate and break down the pieces a little bit further into that. So, but the biggest takeaway here so far is just keep testing, keep trying things out. You know, I know campuses are starting up soon, so if you want to really stress test your systems in the next week or so, this is a great way to do that. When I was at Penn State, that's something we did. We pulled down common data sets and we ran it through systems to verify the actual storage arrays and things like that in the back end. So, but yeah, keep testing, especially before your CC star. If you just had an award or you're in the middle of an award or near the end, if you don't have a baseline, it's good to pull a baseline now before you do anything, or even in the middle of something, so you can see actually what your data transfer speeds are. And because these are known endpoints that are tuned very well, you should be able to get very, very I guess, you know, respectable information about what your capabilities are from this program. So from there, that's, like I said, the data set we have includes, you know, 5 or 6 variables at this point in the logs we have. We'd like to, you know, see what else we can gather from this information so far. But the biggest thing is measure usability. What you have now and what you test against here is going to be what you're going to get to some of these larger facilities at this point. So it's good to have them as a baseline to know where you're going to. Something else to look into is if you can look into your flow data at all to see where your transfers are going, where the big elephant flows are on your campus or even external to your campus. But it's good to have the usability and understand what you're transferring at versus what your potential could be. So, like I said, there's, like Doug brought up earlier, there's, you know, you test your perf sonar and you get, you know, whatever speed, but then you do a transfer and you get, you know, a different speed. So there's ways to correlate that data so that we can try to understand, you know, potential versus your usability right now. So some of the times, some of these magic answers, you know, are out there. There's, as Linux kernels get better and better, there's some things we're looking into that support other TCP information. You know, some of the times and during a flow that's happening from a Linux kernel, there's ways that we can actually capture, you know, RTT, you know, a number of TTL, MTU. There's some other pieces around the window size to be able to see when these transfers are happening. And there's some things like that we're working on as well. More recently, a newer kernel are actually starting to report on dropped packets, which is fantastic. So then there's quite a bit of capability there. To, you wish there was some kind of easy button that would say, oh, my problem is this, and you have this, piece come up like that. So we're looking into different features like that to gather different metrics from these systems, so that as you transfer up to these known DME endpoints, can we gather individual data and then have some of these other, some other information about that to help you troubleshoot this. So again, raise your expectations. Different sites were put out there a couple of years ago that were transferring, 4 or 8 parallel streams at, 5 to 6 point something gigabits per second on a 10 gig host with RAID. So the capabilities are there years ago. So try to raise your expectations of where you should be, even with your own infrastructure. And this program's a great way to do that, to see where you're at. I mentioned like a performance level agreement or something like that, or a service level agreement around some of these transfers if you're hosting infrastructure. So if there are ways you can, share this data and then, test it often, this is a good way to baseline it to start. So, especially as, there's different systems out now that, USB 3 and USB 3.1, with an NVMe on it can potentially transfer 5 gigabits a second. I know that's just to a USB drive, but these are things local that to really stop the sneaker netting of pieces like this. If the network between these sites is not usable, and people are going to start going back to like these faster endpoint things and faster local things to move data, and that's what we want to stay away from. So let's just try to keep focused on our systems and using a program like this to do that and make sure the networks are tuned. Also, as networks grow in capacity, it doesn't always guarantee performance. A lot of times, we go with these 40, 100 gigabit networks and we think we're going to get great, more improved speed on this. And sometimes we do, but it's not always guaranteed. So ESnet's putting out 2 40 gig nodes. One, I think, just got shipped and is racked. I think we're waiting on a few components. So it should be hopefully running in the next few weeks. And we'll get the DME data sets moved onto that as well. But that is NVMe based. There's a reference implementation here, and I have the stats, I think, here. Yeah, so this is pretty much pulled from that site. But this is a system that is built to tune and transfer data, and just to move data to a local system. So this is something that could be for a campus DTN with local storage. And some of these pieces. So we're going to be testing that out and then adding some systems to that and some data sets to that as well. So that's something coming. And I think there's a talk in a few weeks on that as well. So just maybe, oh, sorry, the poll popped up in here, sorry. So from there, it's like I said, we're also trying to find, sorry, it popped up my screen here. So I guess from a, kind of a discussion standpoint or ideas, things to think about. What I guess we talked about a few pieces in there of the variables we have right now and the logs we have. We'd like to break this out a little further, per data set, try to do per source information, per destination. But then also for each source and destination, try to provide the system specifications on how these systems are set up, designed, even with topologies. From there, it's something that it might be adaptable to your campus or, something that may be way off scale, but at least we want to try to gather some of that information to be able to share out so that we can see what kind of speeds we're getting, but also share the information and the architectures that are out there. Whether it be, a single 1 gig for an instrument, whether it be something for a campus, whether it be something for, a larger facility like that. So, and if there are other data sets like this, we can, contact us offline. We can add and see what other individual specs that are in there to see what, capabilities could be with some of this. So, let me see here. In addition, any other ideas of other transfers to other sites or cloud tests or something like that, we can verify some of that. With the comment earlier about perf sonar too, there's been some tests around running a perf sonar test before that a transfer kicks off with some custom code. That would be, an interesting twist in the future we could look into. as well as looking, trying to identify with some of these data sets what they may look like from a reference data standpoint. So if data set, 12 is reference to, this individual science or this type of research or whatever, to be able to model that so you can transfer something that might be similar to what you have and might produce similar amount of traffic or a similar transfer profile or characteristic that may affect your network, your system, as well as your storage. There's pieces around that too. We'd like to possibly get into this. So yeah, so we can have this, if any other requests or information, like I said, we'll gather them from the chat here and then go into further information. So from there, there's a next piece we're looking into is this idea of building these systems out and some of the data portals. This was, again, taken from the previous slide deck, but the idea behind this is we have some of these data sites that are set up and we can set up a data transfer node, but a lot of times there has to be an entire workflow built around this. So there's a beta effort out there we have right now about building a portal that allows you to build, it's a container-based platform that should be pretty direct to turn around, and then you modify the files to point back to a data transfer node. So that they usually get a data portal turned around rather quickly to be able to get this up and running. So we have more information on that as well if you want to get into these pieces. Again, these slides are from the previous round. So we can get into that, or we can go back to the discussion. It's really up to what people want to do. If there are other questions or anything, we can kind of go from there. So.
All right, well, let's see. We did have a question come in. Let's see. Are there any success stories from DME testing? For example, an institution using the results of DME testing to tune their infrastructure to achieve better performance as a result?
There are known source and destinations that have had a few increases. We are looking at reaching out to them to see what some of these success stories may be from this testing data sets. With this, I have noticed a few, like I said, similar source destinations that have increased, but again, I don't have the reference point of which data set they were looking at, so I can't qualify the success until I know what they're actually transferring for each of these individual tests. So, but that's a note I have to go back and try to reach out to some of these groups to see if it was a successful a baseline and then an improvement, or if it was just a different data set to show a faster number. So, or even an architecture change, but nothing yet.
Okay.
So.
All right, well, we'll wait for a couple more questions to come in. In the meantime, I had launched that poll, and sorry, I should have given you some warning. I was about to launch that. I didn't realize it was just going to pop up on your screen.
I thought it was a system error. So.
The results of that poll are that about a little bit more than half of you participated. We have about 40% of people on the call have done a test already. About 30% have not. And then another 30% have not, but are going to try to test fairly soon. So I guess I'll just pose another question here, and you can type in your answers into the chat room. Of the people who have tested, did the results, were they useful to you? Did they confirm what you already knew, or did they maybe surprise you either in a positive or negative way that forced you to go out and try to look into things? And then also, is there anybody who has done testing or is thinking about doing testing that would like an engagement with Epic or with ESnet to sort of help them go through the process? So I'll just leave those two questions out if anybody wants to type into the chat room. Okay, so Phil said, could you help with a script to automate the transfers so you'd get more uniform data transfer numbers? So that's actually a good question. I'm not sure if we can do that, Phil. Ken, do you want to tackle that one?
Well, I know on the, I think the ESnet testbed, there was been some effort around doing some testing, per sonar testing, that before it kicks off a certain data set. And I think there were a few other sites I've heard mention that as well. I don't know if there's any consistency behind that or if anyone's shared that yet, but we can definitely have that as a follow-up from there. So yeah,
Yeah,
it's kind of
it
see
sounds
the
like
capacity.
Vast says that he has one, so we may be able to
Okay.
make that available.
Okay, great. So I'll write that down.
Okay. John Paul Robinson says, if we need help, who do we contact? I think there's an email address that's listed on the webpage, but the most general way that you can do this is just contact EPIC. So it's epoc@iu.edu or Ken directly. And that'll bounce to the correct group of people, and we'll be able to talk about how to help and what we can do. Chris Kurtz said they were just awarded a CC star for ASU, and now we need to finish the EPIC engagement. That's absolutely true, Chris. We started talking with ASU last year, and the pandemic really screwed things up. So we want to get down there, Chris. Don't worry. We'll get down there soon. All right, anybody else, if you've had an experience or want to relay a question, please type it into the chat room. And I guess I'll throw out another question here. Is anybody struggling with just data mobility challenges in the general case? Does anybody need to talk about portals or need to talk about DTN architecture? You know, those things are all interrelated with the DME, so those are also things that we could assist with. Well, it's a quiet group this week, I guess.
I think Eli had the question there.
Yeah, so Eli's question, are there sites that folks would like to see added to the testing set, in particular to be able to show capability to senior leadership? And that's a good point. The data sets right now are distributed to a couple of key locations that have known good performance because we needed to have a stable control group to test against. If there is another site, whether it be university, DOE lab, anything like that, that should or could be added in, we have the people from Globus working with us on this, so they'd be able to facilitate that if that is of value to anybody. And Phil's comment, you know, using per sonar to do a simple iPerf3 test. Yeah, that gives you a good memory to memory. And unfortunately, Phil, with regards to SC20's virtual stuff, there isn't going to be an actual physical SciNet this year. So while it would be possible to sponsor something along the lines of, you know, a big supercomputing facility making a data set available under the guise of being involved with SC20, it wouldn't run over SciNet infrastructure. So we'd run into a similar problem of just not being able to validate or know if something is going to be working as well as it would if we designed it.
Yeah, if there are other, like I said, ideas of how to gather the data, even use as data sets for, you know, testing, like Phil was just mentioning, what would normally do for supercomputing, but, you know, there are ways to even do some of that testing now using these data sets across different infrastructures. You know, feel free to, like I said, that's what this test is for, so.
Yep. Chris notes involving the research, the regional networks in the country is probably a good idea. You know, in their case down in Sun Corridor, you know, maybe having a data set located there would be a good idea. We could certainly look into that. Another question is, are we making these results public and pushing them to a public dashboard? Right now, no. The results are sort of gleaned from looking at the log files, I believe. one reason why we wouldn't want them just showing up automatically is that we like to be able to add context to the results. For example, we're dealing with a lot of different capabilities at sites here, and we don't want to use the same measuring stick to compare a 1 gig tester with a 400 gig tester, right? So at the same time, we want to make sure that we're conveying reality and also adding context to whatever results we get. For example, if a 1 gig connected site is getting, 999 megabits per second, that's pretty good, right? And we want to be able to really champion those use cases where we can. So Inder wants to know, in addition to CC star, is this approach compatible with the NRP nodes installed and it is part of their testing matrix? I actually can't answer that question. If somebody, what was that, Ken?
I'm not sure either, so.
Yeah, so if somebody from NRP is on and wants to add some context there to the chat room, please do. Sal wants to know, what tools are used for read-write speed measurements on a DTN? If you want to take that one, Ken.
Sure. This is, like I said about that one slide earlier, what tools do we have out there? Right now, the usability measurement is really just the transfer speed. And then from what we can get from there is individual system stats around the CPU, network IO, disk IO, maybe what's going on with the application. I have some other tools that I've used in the past, and they're really with the newer kernels. There's a lot more information coming out of Linux boxes. So if there's a way we can actually instrument the edge or instrument these data transfer nodes, there might be a dashboard or a way to actually show that data off per DTN. I know that there's some effort at what's going on in the PRP, NRP dashboards and things there. There's some individual host-based stats that are being pushed back to a central monitoring system that is showing some of this information. I have some test scripts and some other test data sets and I guess test models that verify some of this information, including like when you see a transfer going off, you can see what application is doing, the amount of bandwidth. So I did this the other day on a different call, but I kicked off a live transfer, and on the live dashboard, you can actually see the transfer, peak up to the transfers in real time. And then from there, there's other information. You can correlate CPU, network IO, disk IO, things like that on, different panes. I guess different displays, I should say, so that you kind of see where these, where the bottleneck may be or where, you may be held back. So the instrumentation is getting better for some of the older kernels to the newer ones. But like I said, there's no magic. I wish it was like the old, what would they call the old Internet 2 detective, which is the stoplight thing. So if there's a way to guarantee that, I mean, I've had a few conversations with some people about a data transfer, like mean opinion score or MOS score, like in an old, voice system. If there's a way to do that, but the infrastructure is so interoperable and interdependent that there's this. I guess basing it off, I say it may be a persona or an iPerf test first, and then the transfer after that, we might be able to say, here you are within 20% of your network capacity, and your transfer capacity is this. That may be the first ratio we've talked about that we may be trying to get people to measure against. On the other side of that, there are all the other variables that might go into a system. Like I said, when you're troubleshooting one of these transfer problems, is it the network? Is it what's something in the system? Is it the dreaded MTU mismatch somewhere that comes into this? And there's going to be ways that, and some things we're working on the ESnet testbed that might be able to come out with some of this information and be able to present it so that we can maybe cut the troubleshooting time down with some of these individual system metrics. And so having it directly on, having the instrumentation directly on the data transfer node, independent of whatever networks in between, is kind of the approach we've been looking at. So, so hopefully we'll have some more information about that pretty soon. So we'll see. But like I said, feel free to reach out if you have any questions. So.
All right, well, the NRP question has been answered a little bit in the chat room. There are some Fiona nodes out there, so that's in progress. Another question is, how do you access flow-level TCP metrics in a Linux environment using SS, netstat, or anything else?
Some of the later kernels, I think 3.18 and I think 4.4, and then the new 5.4 kernel they just have new features built into them. So there's ways you can extract some of that data out and present it in, and trend it if you dump it to Prometheus and Grafana. If you run some just JavaScript, live dashboards, things like that while a transfer is happening. There are some individual tools like that we can share if you want to. Something we've used in the past was host sflow. It's an open source hook that will go in and grab anything from your system D metrics to CPU, memory, network IO, disk IO. There are new hooks in there to show Docker statistics, as well as even if you want to start gathering GPU metrics. And then, like I said, there are some newer kernel modules that have enabled the ability to go into some of the other pieces around TCP diag, MTU, TCP window, and push all that out as a JSON object too. So I think Joe Breen just mentioned Performance Copilot's another way to look at it. So there, like I said, there's a couple tools out there that we can actually we can review as part of the performance project or something like that. So.
Okay, and thanks, Joe, for adding that. Rune would like to know, how much different have results been with integrity checking on versus off on average? That's a great question, Rune.
I don't think I have that data in the logs. I will double check that and I can reach back out to you directly. So
okay.
Sure if that's something the logs we have right now. There might be a way to get back and gather that. I think each individual transfer has a transfer record number or associated with it. So some of these transfers that we may see different results on, we might be able to go back and try to look up some of that data. So.
And Vas may be able to add something there as well, which he did. He'll go back and extract that from the usage data. So thank you, Vas.
Thanks. Yeah, like I said, I think some of the hooks are out there to grab some of this other metadata, but right now we're just focusing on the usability measurement of what is the data transfer speed. So, but some of this metadata may help, in troubleshooting as well as modeling some of these transfers. So, thanks for the feedback.
All right. Well, I'll put out a final call. If anybody has any last questions, please type them in. And thanks again, Ken, for presenting. We'll make sure that we get the webpage updated to put in some of the new information, as well as some of the early reporting information. And I'll also post the slides and the recording of the talk after we complete. So while we're waiting for the final couple of questions in here, I can tell you what's going on next week. We're going to have Alan Winery from University of Hawaii, and he's going to be talking about IPv6. So that's going to be more of a tutorial talk that he gave at an Internet 2 conference, I believe a year or two ago. So hopefully if you're able to join next week, please do so for that. And looks like we have one last question from Inder. Are there challenges that you have observed with the age of DTNs as the CC Star program runs through many years of funding?
Yes, actually, we've had a handful of calls on this and a few from some other Epic reviews. One is the sustainability. Sometimes these systems are purchased and the life cycle funding hasn't been planned or budgeted appropriately, and then you're kind of left with what you have. So there's a spreadsheet and some few other funding, I guess, ratios and things like that we have a spreadsheet on. We're verifying with a few people to see if these models look appropriate to do modeling. Same some of the transfer nodes, we're looking at some of the other transfer speeds with some of the older kernels were inconsistent. But in the recent tests, I think from 2000, I forget what those other tests were, but the parallel transfers have increased a little bit with some of the newer kernels and some pieces like that, as well as CPU clock speeds have gotten better. If you have bought a clock speed, I think I don't really have a good baseline metric on some of that. I think it's really dependent on the actual sites and things like that. But as clock speed increases, it helps TCP with the transfer, and as obviously other speeds increase. But the idea of sustaining some of these systems, as well as your CC star funding on that, we've done some ratios on total research revenue from a campus down to what these individual DTNs cost, or what the CI costs, or what a CI engineer costs to a university. And some of these ratios are very, very small, but they're just not planned for appropriately. And so there's some better financial planning we could share with some of that, that get you into a small ratio where you could actually go out and start budgeting for these things to sustain them over time. So.
All right, and then the follow-up to that was just saying if we could get any additional metadata about the DTN nodes themselves, that would probably be very useful.
Agreed. It could definitely help model out what the data transfers were, as well as maybe the reference architecture of where the data transfer nodes sit, or how they're deployed with the topology. So.
All right. Well, that's all the questions that we had. So thanks again, Ken, for going over this. And we'll talk to everybody next week. Hope everybody has a good weekend.
Yeah. Thanks. Appreciate it.